Hi, my name is Agam Singh and this is Lab 2, Lines of Charge. In this lab, we try to truly understand how charges work and how they interact with household items. We use tape to demonstrate how neutral objects can become charged and how we can figure out their charge and the number of electrons they've acquired or lost. This is done by applying a base tape on top of a table and applying another tape on top. The top tape is then quickly ripped off from the bottom tape, acquiring some sort of charge. Then a series of experiments are done to these tapes to figure out a following of results. I redid this lab and got the same results. We also float two tapes above one each other and find the distance between. This can help us find the excess charge. And the purpose of this experiment is to determine approximately how much excess charge is on one piece of Scotch tape by assuming that the charge is distributed evenly across the length of tape, instead of assuming that it's a. As you can see below, you can see the floating tape experiment, and you can also see how before we assumed that the tapes were point charges, but now we assume that the charge is evenly distributed across the line of tape. In this lab, the assumptions that were made were that both tapes were neutral before we charged them. The charge is distributed evenly across the length of tape. Both tapes have equal net charges, and we ignore any air resistance during the lab. Here is the data that we collected. The length of one piece of tape was 0.202 meters. A clear tape is around 1 gram per meter. The mass of my piece of tape was 1.5 times 10 to the negative 4th kilograms. The distance between the two tapes when they began to float were 0.023 meters. The magnitude of the gravitational force can be found by multiplying the mass times the gravitational constant. So I got 0.00147 newtons. And the magnitude of the electric force can be found by doing k times the charge squared over the distance squared, which is the same as the gravitational force of 0.00147 newtons. On this slide, you can see that we use Coulomb's law to figure out an equation to find charge. We assume that both pieces of tape have the same charge and both are treated as a line of charge. On the top, you can see that I calculated the charge for a point charge, but below you can see that I calculated for a distributed evenly across line. I use the equation 1 over 4 pi E naught times delta Q over R squared, and I got that the charge would be 3.045 times 10 to the negative 8th coulombs. By assuming that the tape is an evenly distributed line of charge, I got that this answer was 69.4% more accurate than assuming that the tape was a point charge. This is my code for lab 2. We have the constants on top. Then we use our code from lab 0 that created our electric field. From there we create our top and bottom tapes. Then we create arrows for our gravitational force. Then we create an arrow for our electric field force at every point. And then we have an overall net electric field force. Then we print out the magnitude of the electric force, the magnitude of the gravitational force, and print all done. This is the output of lab 2. The deflection is 0.023 meters. The red and blue spheres represent the two U-tapes that are evenly distributed line charges that are separated by some distance d. The green arrows represent the electric field at each point that are evenly distributed across the line. The white arrow shows the net electric force, and the yellow arrow represents the gravitational force acting upon the floating tape. The code prints out the charge of the U-tape, the electric field, and the gravitational force. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get with your experimental data to produce a point charge model to the value you got with your line charge model. As shown, the point charge model produces a charge of 9.3 times 10 to the negative 9th coulombs, and the distributed line charge model produces a charge of 3.045 times 10 to the negative 8 coulombs. Using the equation below, we can see that it is 69.4% more accurate to use the line charge model. These estimates differ because Lab 1 assumes that the entire tape is a single point charge, and Lab 2 assumes that it's an evenly distributed line of charge. The value of Lab 2 is much closer to the real charge value because it breaks up the tape into many individual pieces and calculates the electric field of each piece. Then it adds them through superposition, so the value would be closer to the real value. Thank you for listening, and I have attached the glow script code for Lab 2 below.